Hey everyone, today we are diving into one of the most exciting shifts in AI right now, and that is agentic AI. You have probably heard this term many often, but what does it really mean? In simple terms, agentic AI refers to the AI system that can reason, plan, and take action autonomously. It not just respond to the prompt, but actually work like an agent that can complete the task end to end. In this section, we will talk about how OpenAI is pushing this forward with their new OpenAI Agent SDK. We will cover all the components that make an agent powerful, having reasoning, memory, tools, and reliability features. We will be creating agentic AI application from scratch, and we will see some of the cool stuff offered by the OpenAI. So, without any wait, let's get started. So, what is agentic AI? The core of the agentic AI is the agent. Agent is always equipped with the LLM. And you know the LLM is like a brain. Agent contains the memory. The memory can be of short-term or long-term memory. So you might have seen in the ChatGPT application where all of your conversation gets saved. So that is using the long-term memory. But sometime you may be building application where the memory need not to be stored and it has to be in the only in sessions. So in that case, we will use the short-term memory. The AI agent once receives the user request, then it applies a series of thoughts. That is the planning. The planning of the AI agents includes reflections and the self-critics. It can apply the series of thoughts to attain that response. And finally, when it determines that what actions to be taken, then it invokes the tool. So tool can be example here like calendar invocations, calendar API. It can have the access to the calculator related methods. It can have the code interpreter. It can perform search. It can invoke the API database call. So it is just like a glue code where you used to write the coding logics. So AI agent invoke and perform all such operations autonomously. So that is the agentic AI behavior. Let's see a real use case of agentic AI application. This is the example of a chatbot equipped with the agentic AI behavior. Unlike the traditional AI chatbot, where it gets the request and it looks at to the some predefined answer and it responds, this agentic AI chatbot does very smart things. So let's see a demo. User is having an internet connection problem. It says that its connection keeps dropping every few minutes. So what should I do now? So it writes the problem and it says that can you please check why is that happening and press send button. So as you can see, the send button pressed, then agentic AI application starts thinking that understanding the problem, it plans the resolution, it is acting on that, and it also sends a communication. Once it performed all these operations, you can see it responded with the text that I have identified and resolved the issue. So you can see that AI agent in this case is not just responding the text-based response only, but it performs certain actions. But we don't define those actions in predefined manner, deterministic way that it performs in that sequence. In this case, agentic AI application internally performing the operation autonomously, it knows what to do in what case. So that is the real behavior of the agentic AI application. That is very cool demo, isn't it? Now let's see how people can start building the agentic AI applications. So we all are from different background, some from the coding background and some from the non-development background. So people who are from the non-development background can start their journey of the agentic AI application using the low code and no code platform. So this low code no code platform offers the drag and drop features and some configurations where coding knowledge is not required. Some of the top key players of the low code no code platform is like Copilot Studios, N8N and Zapier. You don't need any coding knowledge. You just have to do some drag and drops, perform some of the integrations, give some API keys, and it starts working. While the other case where the developer want to build a agentic AI application, they can use the SDKs. The SDKs are written in many languages. For example, Python, .NET, TypeScript, and Java. Some of the top key players in the SDK which supports agentic AI application is OpenAI, AutoGen, LangGraph, CrewAI, and LangChain. In this video, we will be only focusing on the OpenAI part. Now let's see some of the components of OpenAI Agent SDK. So we will discuss all this in very detail, but OpenAI Agent SDK offers these many capabilities. It has the agent capability, means you can build the agent using the OpenAI SDK. And as we talked about the tools, so tools are basically the individual methods or the concrete implementation of your business logic, which agents can invoke autonomously. It has the context behavior, means the agents can communicate to the other agents and they are knowing the context as well. Security and reliability is very important aspects when designing this such kind of applications. So for this, the agentic AI application in OpenAI SDK offers the guardrail. We'll discuss the guardrail in details later. It has output types where you can define the format of the response. You can stream the responses. So you might have seen that in OpenAI where user is typing the request, their prompt, and then it starts thinking and it start getting writing the text as soon as the response is available. So it's just like a streaming the text directly into the output. Then hands off. So handoffs are very cool feature in OpenAI Agent SDK. In some cases where one agent is not capable of performing the operations, then it can hand off to the other agent who is more sophisticated and developed for that specific purpose. So handoff is only for that. We will see that in the detail. And obviously the tracing, which is very important aspects that displays all the tool calls and all the token back and forth callings in the internal systems very clearly. So tracing is only for that. That is for logging and monitoring purposes. So OpenAI agent workflow. So this OpenAI agent workflow shows a typical workflow or the typical components of how the OpenAI agent SDK's components are linked to each other. When you define the OpenAI SDK agentic AI application, then the most important part is runner. So runner is just like an orchestration which takes the user query and perform the operations. A runner is associated with the agents, an agent is associated with the tools. So we will see all that in the demo later, but just to understand how components are linked to each other, we are looking at here. So agent is basically can perform the operation itself or it can utilizes the tool. So tool, as I said that it can have many tools, for example, function tools, which is basically writing the functions which can perform certain operations like a glue code. And then web search, it can perform the search going onto the internet. It can have some stocks and Yahoo Finance related search as well, file search and computer related to, for example, local directory exploration. All this can be wrapped into the tools. So tools are very important components in OpenAI agents. Some tools are inbuilt, offered by the OpenAI, and in the marketplace also it's available. And most of the time you will be building your own tools. Obviously, agent cannot perform itself anything. It has to be equipped with the LLMs. So as we discussed also in the architecture, an agent is always have some LLM associated with it, which gives the power to think and reason. And runner has the memory, short-term and long-term memory, which remembers the user conversation and resume the conversation from where the user left. The agent can have the guardrails as well, means the guardrail can be applied, for example, input validation or output response validation. So guardrails are basically checking that whether user prompt is having any inappropriate text or any abusive language. Or similarly, the output response can be validated, which means that our agent should not be responding something which is not it is not supposed to respond. Then a run artifact, which means that when the runner is complete and agent has done its job, then you can find the result. Okay. And then you can have the tool call item that what tools have been called, how many handoff happens. And obviously we discussed the tracing. So tracing is basically tracking all the invocations, all the communication happening so that you have the clear visibility of that, what events are arised, and how many calls happened, so that you can track the cost and the flow of your application. The OpenAI agent guardrails are very important as we discussed in the previous sections. So OpenAI guardrails basically allow certain things. For example, topic, checking the relevance classifier, which means that the user query is whether off the topic or not. For example, you have designed a customer chatbot for your company. So the customer chatbot application should be only responding to the queries which is related to your company policies or your company related data. But it should not be responding any generic information. For example, what's the capital of Delhi? So these are some of the use cases where the guardrails can be applied, which can check the input validation. It can also detect some of the harmful input. For example, any abusive language are written or any contents which is inappropriate. And then it performs some of the risk rating. For example, it can rate the input quality and the output quality so that your agent can decide whether to respond this query or not. It can also filter the PII information. For example, user is giving some of the personal information, maybe providing the credit card or CVV number, bank account number. So this safeguards user from the fraud. It can have some rule-based protections, like it can have some very sophisticated rule engines which detects the input and output quality of the request or response. So that is about the guardrail. We'll see that in the detail as well, but this is just for theoretical purpose. You know that what guardrail means. It ensures the safety and reliability of your agentic AI applications. So a very awaited slide, which is the Hello World application. This is especially for the developers who want to get start with writing the agentic AI application. And it is very simple to understand. I'm using Python here, but language is not a barrier. You can always use any of the SDK available, like TypeScript, Java, or .NET. But this is Python, very easy to understand. So you can see here, I'm importing some of the dependency, which is agent and runner from the agent class. To create an agent, you define the agent is equal to agent and you specify the name and instruction. The instruction is very important here. Instruction is like a system prompt. So whatever the system prompt you define, this agent will behave accordingly. Later, once the agent is defined, you can see I'm using the runner run.sync and passing the agent and writing my query that write an article on the benefits of AI. And to print the result, I see result.final output. That's simple thing. We build an agent and we invoke that agent and we print the result. So this is about having the Hello World application. Next, we talked about the tools. So in the previous slide, we talked many things about the tool, but let's see what the tool means. A typical tool is like a custom methods which can perform certain operation. In this case, again, I'm importing some dependencies and function tool here. So this function tool is a decorator on the function, and I'm having a get weather function which takes a city as a parameter, which is a string, and it returns the string as well. I'm defining a comment also here which says that return weather info for the specified city. And then I'm returning the whether the city is sunny. Although I'm hard coding the response, but in real case, you will be actually calling the API and getting the weather on the real time basis. But this is just for the demonstration purpose. As you can see that get weather is a function which takes the city. Now this comment is very special here because when the LLM reads this function tool, then it understands that what this method does and what parameter it accepts. Now the function tool, how this is attached into the agent. As you can see, again, we are creating an agent, giving the name of the agent, which is weather agent, defining the system prompt that you are a helpful assistant that provides weather information. I'm defining a model GPT-5 Nano. You can define any model on your choice. And then in the tools section, I'm specifying the get weather. Now, when I invoke the runner.run async and passing the agent and ask the query that what is the weather in New York, then The agent think itself that do we have any tool to fulfill this request? And yes, it finds that it is about asking the weather in the New York. It determines that this tool can help here. But the important special thing is that it determines that what should be the parameter of this method, which is city, and it extract the city, which is New York. Internally, it passes this New York as a parameter, and in the response, it gets the weather in the city is sunny. And as you can see, the output is the weather in New York is sunny. Next, we have a handoffs. And this is really very cool feature which makes it autonomous agents. So let's see how handoff works. Again, I'm importing some of the dependency agents and runner, and then I'm defining two agents, booking agents and refund agent. Same syntax, but I have just added it here for simplicity purpose, not given any detail. But you can think of this as an agent and refund agent is another agent. Then I'm defining a travel agent, which is agent and its name I'm specifying, which is travel agent, and I'm giving a system prompt saying that it helps the user with their questions. If they ask about the booking, hand off to the booking agent. If they ask about refund, then hand off to the refund agents. And I'm defining the handoff construct here. You can see I'm passing an array, booking agent and refund agent. Now, when I write a query like this, can you book a flight from London to New York and check the refund policy? Then you know what happened internally? It understands the query and thinks that okay, I need to call two different agents one by one because the query is about invoking two different things. So for flight booking, it will use the booking agent, while to check the refund policy, it will invoke the refund agent. But you see, we are not specifying anywhere that in what case what to be done. It all automatically happens through the LLM and handoff available, it invokes accordingly. So that is about the handoff. Next, we have a memory or sessions. So it is very practical in many chatbot application. You see that the conversation always persists. In some cases, the conversation may not need to be persist. So in such cases, let's see how to do in this OpenAI SDK. So if this is in-memory database, then we specify this like session, SQLite session, and user underscore 123. This is basically the user ID. And we don't specify any file name. While if you want the persistent database, although this in this case we are having this stored in the file, but you can connect this into the more external database, more sophisticated way. So in this case, I'm defining here conversation.db, which means that this is a persistent conversation. So how to use this session? We again define an agent, which is calling assistant and giving that you are a helpful assistant. Now I'm invoking that agent runner.run, passing the agent and asking that, hello, can you write an article on the importance of the data privacy? And I'm passing a session. So this is a very important keyword here. This is the place where we declare the session, that how much or the persistent storage is there or in memory persistent should be there. So all this specification goes with this session parameters and we print the result. So that is about the memory or sessions. And the next one is tracing. So we talked about this tracing. Let's see how it works. Here we have declared a tool called get weather. It is again taking a location and returning the weather in this city is sunny with a high of 75 degrees Fahrenheit. Then I'm declaring an agent, calling it my agent, and I'm saying that you are a helpful assistant and you can greet the users fetch weather info, which means that it can do both the things. To enable the trace, we write with trace construct here and giving the agent workflow as a trace name. So first input is that hello world, what is the weather in the New York? Then we invoke the runner and it prints the output. Second time, I'm again calling the agent, but different query and print the output. So as you can see that we have invoked the agent two times. It might be that the agent has invoked this get weather for multiple times or one time or may not be having multiple calls because It has the history, it knows the things. All this happens, all this decision is taken care by the agent, or you can see the LLMs. So we don't have any controls on the tools invocations or the agent invocations. In such cases, at least we need the tracing, the proper tracing of the internal calls. On the right hand side, you can see how the tracing window appears. This you can check on the different tracing provider. As you can see, we are using OpenAI. So OpenAI also provide the tracing. But if you are using a different model such as Grok or Gemini, then they have their own tracing tools and web portal. So you can see that I'm defining OpenAI agent trace agent workflow, which is the same name as agent workflow. And then it invokes the hello world. The agent runs and it prints the hello world. Then it responds, and then it gives you some of the information that how much it cost, how much dollar it incurs, and it also invokes some of the tool, what time it took to invoke this tool, and how many tokens are back and forth transferred to LLM and LLM processed. All these low level detail you can cover with this tracing tool. So nothing will be hidden, and you will understand that what are the thought process applied internally by your agentic AI application. So why to wait? Let's start building all these applications from the VS Code. Let's get started. So let's build an application called Travel Agent application. As you can see, user is asking a query called book flight from Delhi to Mumbai and let me know the refund policy. This query further sent to the travel agent. Travel agent is the lead agent here. You can say that it is a supervisor agent. The travel agent starts fetching the conversation from the database. If there was any communication happened in the past, then it will utilizes the data from the communication. Otherwise, it will create a new session in the database. Then you can see it is connected with two different agents called booking agents and policy agents. The booking agent is having further three tools: search flights, list all flights, and book flights, while the policy agent has one tool only: refund policy. So as you can see, the travel agent will take a look at the query and determine which of the agent has to be invoked first. From the query, it is very clear that both of the agent will be utilized here because it is asking for booking the flight and refund policy. Now the request goes to the booking agent, and booking agent further look for the search flight. While searching the flight from Delhi to Mumbai, the booking agent noticed that the date is missing. So it will prompt user back that you have to provide the date of travel. Once user provide the date of the travel, it again goes back to the booking agent and booking agent try to find the relevant flight. After finding the flight, it may give the preview of the flights or directly book the flight. It depends on how LLM behaves at that time. While user, if asked sometime that can you list down all the flights, then it can utilize the list all flight tools. After booking the flight, the travel agent further transfer the request to the policy agent, and policy agent look for the refund policy as per the user ask. And once it finds the policy, it returns the response back to the user. So you can see that travel agent is triaging the query and hands off the request to the appropriate agent. It can do this in the same call or it can do in one by one user request and response cycle. So I hope this is the clear architecture. So I hope this clears the architecture of the application we are going to build. So now next, let's start writing the code. All right, so I have opened the Visual Studio Code and let's start writing the application. So before we begin writing any code, we need to do some of the basic stuff first. For example, we have to first create the virtual environment. The virtual environment has a very important role in the application. When you write this command like python exe mvenv and give the virtual environment name, then it creates a folder venv in your local drive. All the dependency used in this application will be stored in this venv. Without the virtual environment, the dependencies will be stored globally and hence it may conflict with the other application or other dependencies. Then we have an environment file. For our application, we will be using these four environment variable names. We are using Azure OpenAI key here. So that's why we are writing this way. Otherwise, if you have the OpenAI key, then you can write the OpenAI without writing the Azure here. So for interacting with Azure OpenAI, we need API key, the Azure OpenAI endpoints, and the deployment name and the version. Please ensure that you replace it with the correct value. Next, we have a model.py. So here I'm having the declaration of my Azure OpenAI model. Let's understand this. So I'm importing some of the dependency which is needed for setting up the Azure OpenAI. I am loading the .env, which is loading the environment file. Then I get the deployment name from the environment file. I'm creating a client for Azure OpenAI and then defining the model like this. We will be using this model in different agents and we'll see that in later. Now all of our agents will be kept inside into the AI agent folder. Let's see what it contains. We have a two agents as we saw in the architecture, booking agent and policy agent. So let's understand this. In the architecture previously, we have seen that the booking agent contains three different tools, which is search flights, book flights, and list all flights. So as the name suggests, it does the operation based on the name. And it is decorated with the function tool, which marks this as a tool. The search flight contains expect three parameters: origin, destination, and date. Then it returns that the search result of the flight. Similarly, the book flight contains again the same parameters, but it also specifies some of the description here. For example, book a flight given the origin, destination, and date and return the booking details, including the reference number. And then it further specifies the parameter descriptions. And in the last, it returns that the flight from this origin destination on the date is booked and it is giving the reference number. Remember, it's a demo application, so we are not integrating any live app API or live applications here. So it will give the dummy data. The third tool is about listing all the flight. So it also describes that what this tool does. It says that list all the flights in the sample data with airline, from, to, price, and duration fields. And then it specifies the format of the flight and it returns the response. Once you declare all the three tools, then it is time to create an agent and associate these tools with the agent. So I have created a booking agent, and as we saw earlier that you have to define the name of the agent, I given it booking agent, then system prompt. So here I'm specifying what the booking agent will do and what it will not do. And in case of any information missing, then it should ask the clarifying question before it performs any operations. And in the down below, we are specifying the tool, search flight, book flight, list all flight. This is all array. So remember, in the future, you can expand these number of tools to n number of tools depending on your requirement. So which means that it has the chance of extensibility as well. And in the last, we define the model. So remember, we declare all this model specification in the model.py. Here we are using Azure OpenAI model. So we specify it here. Same way, let's take a look at the policy agent. The policy agent is having only single tool, which is get refund policy, and it expects the origin. So now you see that I am again in the same fashion specifying the description of the tool, which is return a simple refund policy string for the given country or origin. And then I'm specifying the origin details, which is a parameter, and then some crafted response, for example, refund policy for the origin, and it returns some text which is about the refund policy. Remember, it will return the same text for all the policy, all the countries. Okay. So this is not the real time policy fetch. And again, in the same fashion, once we have the tool ready, we create a policy agent, again specifying the name, giving the system prompt, and specifying the tool and specifying the model. So by this stage, we now have the sample data and two different agents are ready. It is time to build, to combine all these things, integrate everything, and create a supervisor travel agent. So let's start with the main.py file. So as you can see, this is very empty file. We will start from the scratch. So now I will import some of the dependency. For simplicity, I will not be typing the code here on the recording. Otherwise, it may feel so boring. So let's utilize most of our time. So first of all, we have to bring all the dependencies which is required to build this agentic AI application. As you can see, we are again importing some of the important dependencies, which is OpenAI response and then AI agents from our local folders, booking agent and policy agents. Then I'm importing the agent library, logging and asynchronous related and nest async again, and then the model. Then we also write some of the logging specification, which is about saying that log, show the logs only, which is the error message. We don't want to show the warning and the info messages. Next, we define the travel agent. So travel agent is specification is here. So again, in the same fashion, it's not new code for you. I hope that you have been understanding this very clearly. So this seems very familiar to you. To create a travel agent, we again specify the agent class here, specifying the name of the agent and giving the system prompt that you are a travel agent. Always greet with the user by their name if it is available in the memory. Otherwise, ask for the name. And I'm saying that if the query is not clear, then again ask the clarifying question until you are satisfied. And do not provide any generic information and not go beyond the context. Then we are doing a handoff here. So handoff, we have already talked about it, but handoff is again, I'm reiterating that whenever the travel agent find the query is related to any of these agents, then it redirects the instruction to the agents available. It can redirect to both agent, all the agent, or single agent. It depends on the query. And in the last, we are specifying the model. Now, next thing is that we create the memory because we want to have recorded all our session in the database. So we write SQLite session. So the first parameter specifies the you can say the key or the session identifier, and the second is the persistent database file name. So when we run this application, it should create a DB file in our local folder and start recording all of our conversation. So next time when you resume the application, I mean, when I close the application and launch it again, it will resume the query. It remembers all the conversation it had. Now, next, let's define the main method, which is the final bit. So here I'm specifying some of the coloring thing, which is just a fancy text so that our chat application looks properly. Now I'm printing that welcome to travel agent and I'm running a endless loop so that it feels like a this is a chatbot on the command prompt. So it has a very standard code. You might be very familiar with this type of coding. So here I'm capturing the user input. And then if user press the exit or quit, write the exit or quit text, then it basically exited. Or if your user is writing the CLS just to clear the console, so it clears the consoles. And this one is the final bit where the orchestrator or the runner invokes the agent. And we have seen this in the previous demo as well. So here runner.run is streamed. We are basically calling the agent in the stream fashion, means as soon as the response is available, this is spits or this emits the events into the result parameter, into the result variable. And I'm passing the travel agent because this is the agent name. Whatever the user has written, I'm passing that as well as a query input. Then session, which is a database we created earlier, as you see here, and then max turn. I'm here specifying the six number in as a max turn because we only want to remember the last six conversation from the database. And as I told you that the response will be streamed fashion. So we are listening here, the events, and as soon as it gets the response, it starts writing onto the console. So it looks very realistic of someone like typing exactly. You might have seen in the chat GPT, but we will see that in the moment. And then I'm pasting a new line again, and then calling that method in the async fashion. Now it's time to run this whole thing. So remember to activate the environment VENV, otherwise your application will throw error. Okay, just a reminder. Now let's start. So to run this application, we have to write py.exe and main.py because all of our write logic is inside the main.py. So as you can see that it has given a correct prompt that welcome to travel agent and it is asking for user input. So let's say hi. And you can see how realistic the output is that it says that, hello, I don't believe I have your name yet. May I have your name, please, so I can assist you better with the travel needs. And you also notice that travel console.db and the two other files have been created. So this is basically created at runtime to process all these conversations. So let's start our conversation. I want to book a flight from Delhi to Mumbai and want to know the refund policy as well. So from the user query, you can think that this is a very confusing query because here we haven't specified the date. And as expected, our travel agent has reported it correctly and it is asking for the clarification. So let's read what it gives. I can help you to book a flight from Delhi to Mumbai. To proceed, could you please tell me your preferred travel date? And regarding the refund policy on the airline and specific fares, it depends on the country. So it is basically asking that first you specify the travel date. Okay, so let's specify the travel date. I want to travel on the 4th of June 25. And let's see what the response will be. And it says that I found a flight from Delhi to Mumbai on 4th June 25 with Air India. The flight duration is approximately 2 hours and the price is $170. And regarding the refund policy, it will depends on the fare class you select. So you select, would you like to proceed with the booking this Air India flight? So you can see it remembers the actual query and it has not lost the context. It continued serving the response exactly from where it served the first query, which is about uh, finding or searching the flight. Now I say that, can you book the flight, please? So, as expected, it says that your flight from Delhi to Mumbai on 4th June is successfully booked. Here are the details: Air India, date, route, and duration, price, and booking reference number. So how cool is this? It is responding with with the request and response. So you can see it remembers everything in the context. Now let's do one thing. We exit with the application and relaunch the application again. And this time, let's say we ask the query that I forgot my booking ref number. Let's test what the model comes. Oh wow, it says that Mukesh, your booking reference number from Delhi to Mumbai flight is 4th June, FL123456, blah blah blah, which means that it remembers the previous conversation and it is able to understand my intent here. So that means it's a contextual search. Now let's play some of the more query. I want to see list all the available flights. And it start writing the flight, which is Air India, Delhi to Mumbai, 2 hour, and other available flights also it has mentioned, right? You can see it is listing all the available flights. And if you remember, I have explain this, where this is all coming from. This is all coming from our data files. Definitely, you should try this application in your local. All right. So you can see with this query, it was able to transfer or hand off the request to the booking agent. And the booking agent has wisely selected the tool. In this case, list all flight was selected. So let's start with some other queries. For example, we are asking that what uh, features do you have? So it says that I'm here to help you with the book flight and reference number, list of available flight, and any policy and refund. You can see it's not just hard coding the response that these are the tool names, but it understand your intention and it respond with the same fashion. And let's ask some of the other query. For example, can you give the refund policy for London? The refund policy for booking made in London as follows. And you can see this is the same rule it is giving like hard coded response. But yeah, obviously on the real application, you will make it dynamic. Means you will write the coding part here about the get refund policy. So you will take this origin and look into your database or wherever your policy resides. It can have a vector database or it can be inside an API database, wherever it is, but you will make it dynamically. Here I have hard coded it just to show the capability of agentic AI application. Now in the last, just ask some silly stuff. For example, I forgot my name. I see it is able to, oh yeah, I say that your name is Mukesh, and if you need any travel assistant or have any more question, I'm here to help you. All right, so this is the agentic AI application. Before I close off, let's write one more query which is going beyond the context, and let's see whether this application is able to resist the response, giving the response from the general query. For example, capital of uh, India. And as expected, it followed the system prompts, it honored the system prompts, and as expected, it has not given me the response. And it says that I'm here only available for helping related to the travel, bookings, policies, all those things. And anything beyond, I cannot go. So that's exactly expected from the responsible AI perspective. And your agentic AI application should be having this type of feature. Although for uh, video, although for the demo purpose, we are only covering this, but it is just a glimpse of what you can build the agentic AI application. There are much more things you can do, such as guardrail, but all those things, guardrail and other advanced feature, I will cover in the next section, next video. If you found this video useful, then please don't forget to give your feedback in the comment section. In the next video, we will be covering some advanced topics such as guardrail, security consideration, and more advanced topic. So see you there. Thank you.